Assalamualaikum and very good morning. My name is NURFARISHA. Today I will explain about my ascending sort feature. First, I will show you about my data segment. For my data segment, I created an array called vote codes to store 10 numbers from the user. As you can see in my data segment box, our 10 codes are stored here in the memory address starting from 0 multiply 1001. Now, I will go to my text segment. For our text segment, we collect the codes from the user and I use loops to ask for 10 inputs. I also use a branching like BLT, which is branch less than, and BGT, branch greater than, to check the range. Is it the code is between 1 and 9999? If true, it will save into the memory. If not, the system will show the error message. Now, I will explain to you about my main point, which is my ascending sort logic. In this part, I use a bubble sort algorithm with nested loops. To make the loops work, I use a register ST0 and ST2 as a counter to repeat the sorting process. I also use a ST1 as a pointer to find the code addresses in the memory. During the sorting, the LW, which is a load words introduction, load two numbers into the register ST4 and ST5. So the processor can compare them. Then I use the BLE, which is a branch if less or equal instruction for branching. If the first number, which is the ST4, is a smaller, the process will skip the swap. If the first number is a larger, the SW is a store word instruction. It will swap the position and save the new order back into the data segment. Now I will show you about my live demo. As you can see, I already ran and I already entered 10 random codes. Now I select for the option 4. As you can see, the codes are now sorted from smallest to the largest. This is show that my branching and memory logic are working perfectly, and my unique feature is working perfectly too. Thank you. That's it from me.
I will explain about option 5, sort code descending. The descending order sort feature in the vault security system is implemented using the bubble sort algorithm to rearrange the 10 stored vault access code from the highest value to the lowest value. This feature operates by using two named looping structure, namely the outer loop sort test outer and the inner loop sort test inner, where the outer loop controls the total number of passes through the array and the inner loop compares adjacent elements during each pass. The outer loop uses the branching instruction BEQ sort test print to terminate the sorting process after 9 passes, which is sufficient for the sorting 10 elements, while the inner loop uses branching to determine when the loop should continue or move to the next pass. Branching instruction also occur, particularly in the instruction BGE ST4 sort test not swap, which check if the current value is already greater or equal to the next value. If this condition true, the program skips swap, but if false, the program swap the two values in memory, so the largest value move forward, ensuring descending order. All vault code are stored in data segment, which vault code array, and the sorting process modifies this value directly in memory without using additional storage, while the instruction controlling the sorting logic are executed sequentially in the text segment under the control program counter. Several registers are used throughout the process, where ST0 and ST2 used as a loop counter, ST1 function as a pointer to the array address, and ST4 and ST4 temporarily store the value being compared. When the user selects option 5 from the menu, the program executes the descending bubble sort. All the vault codes are rearranged from the highest to the lowest. The sorted result is displayed on the screen with the message "Code sorted in descending order." This output confirms that the feature worked correctly and fulfilled its intended function.
Assalamualaikum, my name is BATRISYIA and today I will explain about my individual feature. My feature is option 7, which is display odd codes only. This feature goes through the stored 10 vault codes and display only the odd numbers when skipping the even numbers. Okay, I will explain how branching and looping are used in my code. A loop is used to go through all the 10 codes one by one. The loop continues until the counter reaches 10, and branching is used to exit the loop. And branching is also used to check whether a number is odd or even. Each number is divided by 2, and even the remainder is checked. And if the remainder is 0, the program branches to skip printing the number, and if it is not 0, the number is then printed as it is an odd number. Next, I will explain how input is processed and stored. This feature does not take new user input. Instead, it processes data that is already stored in memory. The vault codes are stored as an array in the data segment, and each value is loaded from memory when it is needed. Okay, next I will explain what happened inside the program. For the register, sign T0 is used as the loop counter, and for the sign T1 stores the address of the vault code array. And for the sign T2, it stores the current vault code, and for the sign T3, it stores the remainder after distribution, which is divided by 2. And for the sign A0 is used for the printing output. This program counter moves through the instruction and changes when the branches occurs. Okay, next I will explain briefly about the text segment and the data segment. So in the text segment, the instruction control the execution flow, including the looping, the branching, division, and the printing. And for the data segment, in the data segment, the vault codes array and message strings are stored. Finally, I will show you the demonstration about my feature running correctly. So when I select option 7 from the menu, from the code that I already run, and I use a test case from 1 to 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the program only displays the old vault codes and skip the even number, and then it will return to the main menu. Okay, this confirms that my feature does work, and it shows only the old vault codes. Okay, thank you.
Hi, I'm AMNI BATRISYIA. Today I'll be presenting my vault security system developed in Mips assembly. This system handles 10 access codes, ensuring they fall within a varied range of 1 to 9999. While the program features analytics like finding the highest code and counting even or odd entries, I want to focus specifically on the reverse list logic. Reversing an array in assembly requires manual memory management. Instead of creating a second array, I implemented an in-place swap algorithm to save memory. Looking at the code under the reverse list label, I initialized 2 pointers. ST1 points to the start of the array and ST2 points to the end, offset by 36 bytes. In the reverse loop, I use a BGE, branch if greater or equal check. The loop continues only as the front pointer hasn't passed the back pointer. The actual swap happens using temporary registers ST3 and ST4. I load the values from both ends, then store them back into the opposite addresses. After each swap, I increment the start pointer by 4 bytes. I decrement the end pointer by 4 bytes. This moves both pointers toward the center of the array until they meet. Once the reversal is complete, the program jumps to print ref prep. This section resets the base address and uses a standard loop to print the newly ordered codes to the console so that the user can verify the operations. Okay, in conclusion, this project demonstrates fundamental assembly concept, pointer arithmetic, manual memory addressing, and efficient looping. The system is robust, validates user input, and handles data manipulation directly into the register. Thank you for your time.